Um, what does this talk about? Well, first of all, I work for Red Hat, and I work, as Jonas said, on J and Thea. And the question is, where am I coming from with this? And we had, when we develop J, customers are starting to deploy the stuff, and they're asking us the question, and well, how much resources do I need to, let's say, have 10 users on my cluster, or have 20 or 50 users? And we currently also run a hosted service, which is called Developer Sandbox for OpenShift, which allows customers to try out what J and Code Ready Workspaces, the product version of it, actually could do for them. And to the deception of many, the resources that you need to run developer workspaces in the cloud are more or less the same as you would for local development. There is some sharing, because if you have people in China and there have people in, let's say, the East Coast of the US, they can pretty much share the same machine. But the order of magnitude of resources that you need is the same. And also, if you go from 10 to 20 users, you need to double your resources, basically. So the resource consumption scales order of number of workspaces you run in parallel. Just for kicks, a couple of definitions. Economies of scale, what do I mean by this? It's when I add one more user or one more workspace, the average cost per user workspace actually goes down. What this means is that there is a fixed cost that I have, which is shared among many users, and there's a variable cost or resource consumption that is going up when I add a user. And the Cloud IDE simply is an IDE, a complete graphical system that you can use to build programs, and that is accessible in a web browser. So there's nothing running on your machine. It's all someone else's computer. So what's the problem that actually leads to that bad scalability? And at the root, it's that the tools we're using, at least in J and in many other cloud IDEs, are local tools. If you look at VS Code Java, the underlying technology is Eclipse, which is 20 years old, or you have the TypeScript compiler, etc. And all these tools are not aware that they're running in the cloud. They all think that they're running on your laptop, basically. So there's just no taking advantage of the cloudness of it. The second problem is that the workspaces we run usually share pretty much nothing. So everyone gets their own environment, they get their own IDE, they download their own dependencies, they run their compiler, etc. And there's just nothing shared between the various instances of the IDE running. And the third problem is that many times the workspaces that we use in the cloud are throwaway workspaces. So while your laptop, you probably have your installation and you have your tools and you use that, you don't change that for a long time. You might use it for a year or two without changing anything. Whereas a cloud workspace is often recreated. You might have one just to work for one issue, and then you throw it away and you start from scratch. So the model that we have here is basically like a lift and shift of a local workload or development environment, but we basically graphed on a new UI via the web. So what could be an approach to actually improve the thing? And what I've come up with is actually to pre-compute some of the data that we need for providing the IDE services and save that. And when I say pre-compute, I mean before I start the workspace, right? It's always just around before I create my particular, the workspace for the project I want to work in. And pre-computing actually saves one of the bigger problems, which is when I start from scratch, I always have to start my whole environment and index everything, etc. And that could be, for many things, be done in advance. And the second thing where the resource consumption, disk and RAM savings come in is that we can share many of the pre-computed things among various workspaces. And I've looked just for kicks at the Thea project itself. And when you look at the libraries folder, the node modules, it's around 850 megabytes, whereas the packages where the actual Thea code lives is only about 85 megabytes. So that's a factor of 10 is code that basically almost never changes. So the question is this actually feasible? And what will we have to do to get to a world where we can reuse a lot of that work and a lot of that space, basically. And to determine that, let's start by looking at what an IDE actually does. If you look at your editor, the first thing it does is what I call navigate. And by that, I mean things like go to definition or show the documentation for a method. The second thing is search. For example, you want to know all the classes that start with an A in your workspace, or you want to know all the subtypes of abstract list in the JDK. And the third thing is propose. Like I'm writing code and I invoke control space typically, and the IDE is supposed to suggest things that I might write at this location. And the last function, of course, is producing artifacts. Writing code is no good if nothing comes out of it. So we might produce a jar, we might produce an npm module, we can publish, or in the end, an executable that the user or some server may run. So let's look at these a bit more in detail and think about what we need to do to actually implement that. And the first one is navigate. And by these things, for example, you have public class food stands bar, and I invoke go to superclass or go to definition, go to supertype. And that thing is actually pretty trivial to pre-compute if you're in the same project, so to speak. If it's just one file over, all I have to do is point to, oh, it's this file over there and it's that range. And I can do that well in advance. And this thing never changes unless I change the code. And that computation is, of course, language dependent. That's a bit obvious because you have to, first of all, you have to be able to parse the source code and know what the things are, etc. It gets a bit more complicated if the bar class is actually not from the same project, but it's imported from somewhere else. And that means that the reference that we try to follow might change depending on our setup. So if I update the version of the JDK, for example, the library is compiled against JDK 8, but I use it with JDK 11. Then if I try to navigate to, say, abstract list as my superclass, I'll have to open a different resource and go to a different range in that editor that I'm opening. Again, we can pre-compute that, but we need, instead of having a fixed reference, we have to have some kind of abstract reference and a mechanism to resolve that. The language server interface format from the Microsoft guys calls this a moniker, like that external reference, and that's dependent on module system. For example, I might reference something in a dependency that is an npm module. So to find the resource in the end, I'll have to go look into the node modules folder and open a file in there. Or in Maven, I actually might have to open a jar and open the attached source, et cetera, et cetera. So that's dependent on the module system I'm using. The second thing is search. And the difference to the navigate case is if we think about find all subclasses of abstract list, and that's a JDK class, all subclasses depends on the whole world. I need to know all the things I'm importing into my workspace, or for example, adding to my POM XML in order to know who subclasses all that that class. So this cannot really be pre-computed before I know what's in my workspace. But of course, I can use pre-computed indices for read-only stuff that can be used to execute that query. And it's kind of interesting to know that some of the tools that we use actually exclude libraries from this kind of search. So when you would look for the subclasses, you would only get stuff that's in your own source code that you have in your workspace. Propose is even more complicated. So the example I have here, I have a variable and it becomes pre, and then I invoke completion. So what the proposal engine or what the IDE needs to know at this type, at this point, is what could this be? And in that case, it could be a function, could be polymorphic method call, could be a variable name or a class name. And again, of course, this needs, in some cases, it needs whole world knowledge. And it's also very dependent on the semantics of the language. In this particular case, in Java, it could be a polymorphic method call on the this object, but in TypeScript, it couldn't, because there you have to actually explicitly write this dot, whatever my method is. And of course, again, you could use an oracle that uses pre-computed indices to do that resolution. But again, it's not pre-computable, and it's much more complicated than just the search and the navigate case. And the last thing is compile and link, and that's a bit special for two reasons. Because often the compiling and linking is done by batch processes that are very little integrated into the IDE code. These operations are typically very costly, but they are very rare compared to the other operations. I mean, I might invoke control space 10 times a minute, every 5 seconds, but I'm not building my system every 5 seconds. I might do that twice an hour. It's also a bit special because I know very little about it. So for me, the discussion of that is a bit out of scope. If you know more about it, please discuss it with me. And I think it probably would benefit from some pre-computation as well. And we're going back to old ideas here. Think about SIM files. I think that's from Module 2 or so, that you can use to separately compile your stuff. Or pre-computed headers in C, C++, right? All right. So one thing that's interesting here I find is what is actually a unit of pre-computation? What is the database or the file that should be updated with each other, right? And it's actually stuff where the source code changes with each other when the unit is consumed. And typically those are modules in the module system that the language uses. So for example, when I publish a version of a Maven module, that whole source code is stable between those versions, and I can reference inside that same version, and I know it's not going to change between the versions, right? Or a tag in a GitHub project or an NPM module. And I think this plays together with the generation and interpretation of monikers. So whenever a moniker would point to two different things, I need to basically make a new version of that project in my system where I reference the other modules, so that I can actually point to the right thing. So this is the epic. What will we have to do to actually get to the world that I'm describing? And the first thing is pretty obvious. We need an indexer, something that actually goes through the source code and writes that and generates the whatever format we want. Some people work with language service interface format, but that's just one choice. But it might there might be a standard basically that generates that information, and that would benefit again from the advantages like LSP has, where you can m plus n, m servers and n clients and not m times n. And you need some kind of generator for the monikers, where I say where it's relative to a module on the version of the module. So for when I reference something in a class in an npm module, it's different than when I reference it in a Maven jar, for example. And the third thing we need is a program database service that actually can store all that information and answer the queries that we want. And queries would be something like, what's the type hierarchy on this type? What are the methods that are defined on this type, and on the type hierarchy, and where, who overrides, etc., etc. So we can actually do the references, searches, and proposals based on that. And the last, but by far not the least thing to do would be create a proposal engine using those pre-computed indices, or that program database. And right now we are reusing a lot of the compiler infrastructure for that. For example, JDTLS uses, or VS Code Java uses Eclipse. And so this would be probably the largest undertaking and the scariest. But probably not impossible. A couple of caveats, things that might actually go wrong. And the first one, pretty obvious again, we have to be sure that we can keep the response times low, because we're replacing a local index with something that a machine on the network does, and that machine, ideally, because that's why we're doing it, needs to be shared. So we need to be sure that we have enough power and the appropriate query, etc., structures that we can do the proposals in particular fast. The second thing is, are we actually solving a problem? Because the actual IDE features might not be expensive, as expensive as you think. I just did a little experiment and I opened a decent sized project in a recent version of Eclipse, and the heap size actually is about 300 megabytes. So if you look at batch processes like Webpack for Thea, for example, that takes a couple of gigabytes RAM just to run. So it's to be seen if this sharing, if we just do it for the IDE part, is actually going to, it's certainly going to provide some savings. The question is whether it's relevant. There are some other ways that you can handle batch processes. For example, you could hand them off to dedicated machines that take care of that. Because it's relatively rare, you might be able to get a higher throughput for the overall system if you put that somewhere else and let those guys handle it. All right, just a bit things that might be interesting if you're interested in this. And first of all, this is language server interface format developed by, I think, mostly Dirk Bäumer, the guys that do VS Code at Microsoft. And what it is basically a cache of what LSP does. So it's a file that says, if I was to invoke, let's say, go to definition here, what would the answer be? And I think GitHub Code Navigation is based on that interface. GitHub Code Navigation, when you hover over or you click on a method usage, you can, in some projects at least, it opens up a menu where you can click and it goes to the definition of that method. Other thing I'm aware of is what SourceGraph does, for example. They also use LSIF for their generation format for their when they index stuff. And what they do is search and navigation. But I'm not aware of someone who actually does the proposal stuff with pre-computed indices or pre-computed knowledge. So to sum it up, currently Cloud IDEs are basically a lift and shift of local development. And that's why they scale linearly with the number of workspaces. And economies of scale could arise from pre-computing and sharing stuff, but the tool architecture would need to change considerably for realizing those savings. And that's all, folks. Thanks for listening.
Thank you very much for those interesting thoughts. So did I get it correctly? So this is in an initial state where you do conceptual thoughts, but there's nothing yet implemented, or is there something, some secret prototype?
It's Red Hat. There's nothing secret. Yeah, right. No, we had an effort going on into that, but as you see, this would be a large thing. This is more kind of a research thing for unclear benefit in the end. But well, we're just not sure if it's going to work or what. So currently, we're not working on anything along these lines. I mean, some of the parts are yeah. Sorry.
No, please finish.
Some of the parts are being worked on, and I think that eventually people like the guys from SourceGraph are, I would be surprised if they didn't. Right now they do an external tool where you can do code search and code navigation, but once they have all the data, I would be surprised if they didn't move. I mean, for me, it would be obvious that you start going more inside the IDE, right? Instead of just being a website on the side. Same thing for the guys at GitHub. Why download all the jars if you can just navigate the source based on an index that you already have somewhere? So I think these things are going to happen because they're going to happen as a side effect of things folks are already doing.
I see. First, a comment before I come to the next question. There was a comment in the chat rather than a question. So you mainly talked about tasks that require computation time, and there was a comment from Amar who mentioned that Coder actually uses block deduplication to save storage. So that's probably also an interesting additional concept that you might combine with your concept. And there's a concrete question about slide 16. Would the IDE need to change, or could we add a layer between the IDE and the operating system that could handle the deduplication or the pre-computation in your case? It's probably about the third bullet point.
It's a good question for which I have no good answer right now.
I see. It's good. It's good to admit that, because I mean, it's not a trivial thought. I have another question. Do you have any? I mean, you're probably driven by some experience from practical use. Do you have any numbers on, for example, which task like produce the most cost in current development use cases? Is it storage? Is it computation time? Is it the compilation? Or is it the basic use?
Let me quickly go back to the question before, because while you were talking, I had an idea. I mean, if you have to redo the parsing, etc., if you just basically replicate the source, that's still still going to use the same startup time. You still have to do it, right? But if you could actually map the pre-computed indices as files, probably, right? Instead of so that will be a way perhaps to do that. You'd still have to change the proposal engine, I call it, right? Because if you still do the parsing, then you're not going to gain anything except share a bit of share the source code.
Yeah, exactly.
What was the second?
So,
what was the second?
That might be a huge advantage of the LSP architecture, because you can actually, I guess you could do most of the stuff on the server, and the client actually doesn't even know where the proposals come from.
Yes, of course. The problem is just that you need that proposal engine. That the proposal engine cannot be generic. it needs to be specific to the language. For me, that's pretty obvious. If you can convince me that's not true, that would be fantastic.
No, but the question, interesting question is how the question was meant between the IDE and the operating system, whether that's between, let's say, a browser client and the online workspace, or where exactly the switch is there. But if we interpret the question between the browser-based IDE and the backend, so to say, then there's probably not much to do on the client side.
Could you repeat the second question, because now I've forgotten it?
Yeah, it was actually whether you have any. I assume your thoughts are driven by some problem or some cost that you want to avoid. Do you have any numbers which part affects or produces the most cost, like storage, standby, computation, compilation?
Okay, dollar cost, I don't know. But if you look at the disk footprint, for example, the library folders are generally the biggest. I mean, at least with the code we're working with TypeScript, but probably with Maven, it's not that much different. I mean, it's gigabyte each time you open a workspace, at least for Thea. Computation, a lot of it is in the startup, because when you start up the workspace or you create a new one, you're going to download, in Maven at least, you're going to download all those Maven dependencies each time. And because the compiler actually wants to look at that stuff, and the Eclipse wants to look at that stuff, you can't really shortcut it. The only thing you could do is kind of mount it or something, but then you'd have to, you can't really do the pre-compute tab, because you don't know what's in there before you create the workspace. What you could do is do a big cache and mount that somehow, and to have a shared cache, so you just have the whole universe in there, basically. The Maven server is a cache, or the artifact server. Yeah.
Thank you very much. We are at the end of the time, so we have to switch over to the next session. I think this covered a very interesting topic, especially for the future, because at the end of the day, I mean, you come into the topic with the assumption you will actually save costs, but in many projects that I observe, the cloud-based workspaces, at first they produce costs that you didn't have before, right? Because you still have the local machines, and they were kind of booked on infrastructure, but suddenly you have this new kind of cost. So I think it's definitely worth to think about how to save costs and also energy for the future. So thank you very much for sharing your thoughts.